we consider a very important part of electric circuits, Kirchhoffs rules. We studied Ohm's law to solve the circuit. But when the circuit is complicated, Ohm's law alone cannot solve the network. Therefore, we have to depend on Kirchhoffs rules. So, along with Ohm's law, we must consider Kirchhoffs rules also. So, what are Kirchhoffs rules? There are two rules. One is called Junction Rule. First one is called Junction Rule. Actually, this Junction Rule is related to a junction of an electric circuit. Suppose a current I is coming towards the junction and it is flowing out as I1 and I2. Now, according to this rule, we can write that I equal to I1 plus I2. So, what the rule says is that I minus I1 plus I2 will be equal to 0. That means at any junction of an electric circuit, the algebraic sum of the electric currents meeting at that junction will be always 0. This is junction rule. And this junction rule is based on conservation of electric charge. So, based on that conservation of electric charges, here I read this conclusion that at any junction of an electric circuit, algebraic sum of the currents meeting at that junction will be 0. Second one is called loop rule. Loop rule. Loop rule actually relates with a closed path of an electric circuit. For example, suppose I have a circuit here with two resistances R1, R2 and an EMF E. And a current I is flowing through this. Then we can say that the EMF applied here will be getting dropped across resistance R1 and resistance R2, such a way that the algebraic sum of the EMFs around this loop must be 0. Now, to define that rule, we can take it like this, that in a closed circuit of resistances and an EMF here, the algebraic sum of the product of current and resistances will be always equal to the algebraic sum of the EMFs connected in that closed path. Once again, the algebraic sum of the product of current and resistances in that closed loop will be equal to algebraic sum of the EMFs connected in that closed loop. So, if I take this closed loop as A, B, C, D, A like this, then if I move from A to B, B to C, C to D and D to A, I can write applying sign dimensions. I will be moving along the direction of flow of current. Therefore, minus I into R1, again minus I into R2, and to reach A, I have to cross the cell from negative to positive through the cell, plus E will be equal to 0. That means that I into R1 plus I into R2 will be equal to E. That means sum of I into R1 and I into R2. This is the algebraic sum of the product of current and resistances will be equal to the EMF in that one. Here only one EMF is there, therefore that value will be correct. Now this second rule called loop rule is actually based on conservation of energy. What's that? Conservation of energy. So these are the two rules stated by Kirchhoffs in solving the